Hello students, welcome back to my channel with a very new video. So today we are going to learn about current electricity. So what is current electricity? So basically current electricity is due to the motion of the charges. What is electricity? Electricity is basically, it's a type of energy. So whenever energy flows and electrons move, that constitutes electricity. So basically that is a type of energy. Now let's move forward to the current electricity. That just means that the charges are flowing. They are flowing within the conductor and that just constitute that. Now electricity is simply of two types. One is the static electricity, the other one is the current electricity. So static electricity means when the electricity is due to the static charges. For example, you can say this is the charge plus Q. This charge plus Q is at rest. So that will constitute static electricity. Whenever this charge will start moving, for example, this charge Q is placed within the electric field, so this charge will experience a force. So that will constitute current electricity. So that was all about current electricity. So basically, electric current. Let's study more about electric current now. Okay, students. So basically, electric current is simply denoted by the symbol I. This is the symbol of electric current. What is its SI unit? Its SI unit is named after a scientist named Ampere. That is Ampere. Capital A is the SI unit of the electric current. Now basically electric current is taken as the flow of charges. So what will be the direction of this electric current? For example, this is the circuit I am having. Okay students, this is the positive and negative charges. This is the positive charge, this is the negative charge. And the circuit is flowing like this. Alright students, so basically conventional direction of current is taken in the direction of positive to the negative terminal. This is the direction of current which is taken. But after some time we got to know the point that the current flows from the negative. The current is due to the flow of electrons because the positive ions are static. They cannot move from their place. They are just placed at the place where they are. So basically the current is due to the electrons. So the electrons are flowing, but you can say that if the current is taken in the direction of positive to negative, so the flow of electrons will be in the opposite direction. So basically you can say this is the basically the direction from positive to negative is taken as the conventional direction of flow of current. Conventional direction of current, and this basically direction is the electronic direction of current or electrostatic direction of current. Alright students, so basically this is a conventional direction of current is always taken as the actual direction. Alright students, let's move forward. Yeah, let's move forward to the next topic, that is average current. Average current is basically, for example, you can say this is the amount of charge which has changed, and this is the change in time. Okay, so the average current I will be given by the change in the amount of charge flowing through the circuit and basically the change in the time. And when this time interval become this time interval will reach to 0. Okay, so if I will do I limit t approaches to 0, so that will become instantaneous current. That is how much amount of charge is flowing at that particular instant of time. And this is basically the small amount of charge flows in some delta t interval of time. That is basically the average current, and this is the definition of instantaneous current. I hope students this is also clear to you. Let's move forward. Yeah. So the next question appears whether the current is a vector quantity or is it a scalar quantity. So the answer is it is a scalar, as well as sometimes it behaves like a vector. And that is why we take the current as a tensor quantity. But in actual practice, for your classes and at this point, at this level, you should take the definition of current that it is a scalar quantity. Alright students, let's move forward. basically you can say 2 ampere of current is flowing here, 2 ampere, 3 ampere is current is flowing in. So what will be the total current flowing in this? So as we have taken current as a you can say scalar quantity, so simply these quantity will be added. But if in case we take it to be like you can say vector quantities, then we have to add all the angles and cosines and sines, we have to consider that. But in this case students, we will be only considering that we will be doing the sum, that is this will become 5 ampere. Now let us take another example. Let us say this is the 2 ampere of current flowing in and 3 ampere of current flowing out. So what will be the amount of current which will flow here? Let's say 3 ampere is flowing in and 2 ampere is flowing out. So what will be the amount of current which will be flowing here? 1 ampere. So basically current is a scalar quantity, but it also depends upon direction. Alright students, let's move forward. So let's study about charge carriers. What are the charge carriers? Charge carriers are the type of conductors which carry the electric current and make the current possible through the conductor. So for example students, in case of you can say, in case of conductor, solid conductor. In case of solid conductor students, basically you can say these are the atoms and molecules, and these are the free electrons within the conductor. So basically these free electrons within the conductor are the charge carriers, because these free electrons move randomly here and there around the conductor, and thus they constitute the thus they cover whole area of the conductor, and thus they produce the electric current. Alright students, let's move forward. So what are the charge carriers in case of you can say electrolyte? Okay, so let us take the example of an electrolyte. Okay students, so electrolyte you can say, in case of electrolyte, you can say this is the beaker. Okay, in this beaker there is a Na positive charge, Na positive charge, and then Cl negative charge. So basically these ions which are getting broken, these are basically the charge carriers in case of an electrolyte. And these are the charge carriers. Charge carriers are what? They make electricity flow through a conductor or a semiconductor or an electrolyte possible. So that is how it works. I hope students this was also clear to you, the concept of charge carriers. Now let's move forward to a little bit more interesting concepts. Okay, so one thing we know that in a solid conductor, basically there are free electrons, and these free electrons are responsible for the electric current. Okay, and you know, whenever no current is passing through the conductor, for example this is the conductor, okay, and these are the nucleuses. Okay, these are the nucleuses. Okay, these are the nucleuses, and these are the electrons which are there inside the nucleus. Okay, and you know these electrons are moving randomly within the conductor whenever there is no electric field applied. But why don't that thing happen that when we touch a conductor we do not feel electric shock? Why so? Because the thing is that in the absence of an electric field, there is no net current flowing through the conductor. Alright students, so you can write down this line: no electric field, no electric current. I hope students this point is also clear to you. So whenever there is no electric field within a conductor, so there will be no electric current through that conductor. Okay students, let's move forward now. So what I will do is I will apply some electric current on this conductor. Okay, I am applying some, you can say over here, some positive and negative charges I have applied to this conductor. Now what will happen? So there will be some, you know, there will be collisions between these electrons. These electrons will be colliding with each other, with the nucleus. Their path will not be straight. Their path will be like this zigzag pattern, and then they will move out of the conductor. But in this case, we will be getting some amount of electric current. and that electric current will be basically, the velocity with which the electrons will move out of the conductor and they will enter into the conductor, that will be given by this drift velocity. Alright students, now let's understand more about this concept of drift velocity. Okay, so basically whenever these electrons are within the conductor, they are randomly moving within the conductor, but due to the presence of external electric field, they will get some acceleration. Okay, so let us find out firstly acceleration of charge. Okay, firstly we know that force on the charge will be given by F is equals to minus QE. This will be the force experienced by the charge. Now acceleration is basically force per unit mass, which will be equivalent to EE upon m. Okay students, this is the value of acceleration which will be experienced. Now there are lots of electrons which are moving inside the conductor. Okay students, so basically the velocity of one final velocity of the electron will be given by initial velocity plus acceleration into the relaxation time. This tau is a simple term which is used for the significance of relaxation time. Alright students, so let's say this is the v1 velocity and this is the initial velocity of the electron. Okay, let's say tau1 is the relaxation time. They will be facing same acceleration, masses are same, everything is same. Now in the case of second electron, just a second. Yeah. So basically this is the velocity of the first electron. Now in the case of second electron, this will be like this. In the case of third electron, it will be like this. Okay. I will sum all this. So the average velocity will be equivalent to v1 plus v2 and so on plus a tau1 plus tau2 and so on upon n. And this will come out to be minus ef tau upon m. And this is the drift velocity of the electrons. Alright students, so this is the velocity with which the electrons will move when they are knocked out of the conductor. So thanks for watching students. This was all about current electricity. Stay tuned for more.